There's a coal mine in Inner Mongolia where the trucks have nowhere for drivers to sit. Take a look at this truck for instance. It doesn't have a cab, a window, or even a seat. This truck comes with a battery pack, an electric motor, and nearly a 100-ton load capacity, working in a pit that may drop to almost minus 40 degrees in winter. Back in May 2025, in the Yimin open pit mine near Helanbua, China switched on 100 of these trucks at once, the largest single fleet of its kind anywhere on Earth. It has now been a year since then. They're still running, with each truck delivering about 120% of the output of a human-driven diesel equivalent. In the same region of Huilingguo, AT150 driverless trucks have also started plying. So how did a coal pit in northern China end up with the most advanced, clean haulage fleet on the planet? Does the financial case actually stack up? And who else is racing to build them? Back in 2020, China had just around 90 autonomous vehicles working in its open pit coal mines. By 2025, that figure passed 4,000. You can attribute this massive acceleration directly to government policy. In 2020, the National Development and Reform Commission ordered an immediate push towards intelligent mining, setting a goal for automated baseline operations by 2035. However, there was an even harsher driver than this, and that was safety. After years of fatal accidents, regulators recognised that the single fastest way to prevent injuries in a pit was to remove human operators entirely. On a global scale, China was already late to the race. Rio Tinto began testing autonomous haulage in Australia's Pilbara region back in 2008, a fleet that has since moved over 1 billion tonnes of material. But the thing here is China joined roughly a decade later, but scaled up far faster than anyone else. Between 2024 and 2025, the global autonomous haulage fleet grew by 84%, climbing from roughly 2,000 trucks to nearly 3,800. China accounted for most of that boom, expanding its fleet and surpassing Australia, Canada and Chile. This truck was built jointly by China Huaneng, machinery giant XCMG, Huawei and State Grid's connected vehicle arm. Designed from scratch to be driverless, it has no cab, no mirrors and no heater. That saves weight, cost and one entire category of failure. The battery is a swappable 568 kWh lithium iron phosphate pack, driving a motor built to keep working at minus 40. Now charging a truck this size would kill the duty cycle, so the mine swaps instead. The automated station pulls the dead pack and drops in a fresh one in about 5 minutes. By late 2025, XCMG reported nearly 47,800 swaps at Yimin at a success rate above 98%. Then the part that separates this from the Western autonomous mines. Yimin is the first open pit mine running on 5G advanced network with 500 megabits of uplink and 20 milliseconds latency. The truck streams HD video up and the cloud dispatches them back down. A control room supervises the whole fleet over the Huawei network. Huawei's cloud builds a crowdsourced map from the fleet itself. Every truck updates the shared pictures of the pit in real time, so routes re-optimize and queuing at the shovel falls. While a lot of the Western autonomous haulage keeps most of the thinking on board the truck, the Chinese model pushes perception and dispatch out to the network. That is a real architectural fork, and it only works if the radio never drops. The business case in China is not the business case in Australia. Automation is expensive. Research in mining, metallurgy and exploration puts an automated capable haulage truck at $1.5 to $2.5 million before networks and a control room. In Australia the maths is easy. A haul truck driver earns the equivalent of $100,000 to $120,000 US per year, and a big pit runs hundreds of them. In China, the same driver earns $16,000 to $25,000. Industry estimates put payback at 3 to 6 years in high-wage countries, stretching to 7 or 12 in low-wage ones. So labour alone does not explain Yimin. However, here's what does. A driverless fleet does not stop for shift changes, breaks or fatigue rules. Yimin's own advisors say the site once needed 300 trucks and 1,200 drivers to run around the clock. Secondly, fuel is typically 20 to 30% of a mine's operating costs. Going electric at Yimin should cut diesel by about 15,000 tonnes and CO2 by 48,000 tonnes a year. And lastly, in Australian mines, autonomy cut tyre costs by 15 to 20% and extended equipment life by 20 to 30% purely by removing harsh braking. Then the number that ends most arguments here, at Rio Tinto and BHP sites, haul truck accidents fell by about 90% once the trucks drove themselves. Outside of China, Australia still seems to be the benchmark. Rio Tinto runs over 300 autonomous trucks across 10 sites, BHP around 360. The biggest swing is Fortescue, which signed a $2.8 billion deal with Liebherr for 475 zero-emission machines, including about 360 autonomous battery electric T264 haulage trucks by 2030. The first Fortescue Zero battery went into a T264 in May 2026. A month later, BHP, Rio Tinto and Caterpillar began trialling battery electric 793 haul trucks together in Pilbara. Komatsu has now commissioned 1,000 ultra-class autonomous haul trucks. Caterpillar is targeting over 2,000 by 2030. It's spreading past mining too. On the US highways, Aurora had clocked close to 440,000 driverless miles by June 2026. And now China is exporting. CD says it's targeting Australia, the Middle East and Europe. The Chinese numbers are hard to argue with. One supplier, EACON, has over 2,000 trucks running on its system, more than Caterpillar and Komatsu combined. Around 4,100 autonomous vehicles have gone to more than 130 Chinese mining areas. Xinjiang and Inner Mongolia are half of all projects, and coal is about 80% of the trucks. Chinese fleets are mostly wide-body trucks in the 60 to 100 ton class. Western fleets are ultra-class machines carrying 220 to 360 tons. If you count vehicles, China wins easily, but count tons and the gap narrows. And the problems left are unglamorous. Mixing trucks from different manufacturers, holding satellite positioning together deep inside a pit, and rebuilding haul roads laid out for human judgment. What is really happening is two different approaches to the same idea. The West is automating a small number of very large machines, keeping the intelligence on board. China is automating a very large number of medium machines and wiring the whole pit into one network. Whichever ends up cheaper per ton moved is the one the rest of the world may copy. But the uncomfortable truth is that most of the advanced electric haulage fleets on Earth exist to dig up coal faster and cheaper. Fuel, which is not green at all, dug out by clean trucks. While electric vehicles' environmental impact is tied to how the electricity is generated in the first place, in cars we typically see the original carbon debt from production paid back in under 5 years, even from electricity generated by coal. EVs run about 4 times more efficiently than gas cars, effectively due to coal burning more efficiently than gas engines. However, batteries are heavy and these vehicles are huge. We start to see diminishing returns on efficiency with larger electric vehicles. A strong case has been made for larger vehicles to run on hydrogen because of this reason. Regardless, the choice for electric is more about modernisation and accessible technologies here, rather than eco-conscious practices. Whether that counts as progress depends entirely on where you think coal is going and how this may inform and change other industries in the future.